Okay, here we go, guys. We're about to derive the law of sines. It's not too extreme. It's pretty straightforward. Well, I guess it's relative, so I shouldn't be saying stuff like that. But it's relative whether you think this is straightforward or not. But yeah, so we figured out last time that the area of a triangle is 1/2 BC sine A. And so it doesn't matter what area formula I use for this. So I can use 1/2 BC sine A, or I can choose to use angle B. And if I use angle B, I'll have 1/2 AC sine B. Or if I use angle C, I'll have 1/2 AB sine C. And all three of those formulas will give me the same area of this specific triangle. Yay or nay? All right. So I can see here, because all three equations are the same, if I were to solve for them, so I see a half that I can just get rid of. Bam, bam, and bam. And if I divide by ABC if I divide by ABC for this one, then I have to divide by ABC on that one and this one. And then I get something like this. Notice that the B and the C cancel out. And I have sine A over little a equals, and then notice that the A and the C cancel out, and I have sine B over little b. And notice that the A and the B cancel out, and I have sine C over little c. Delta math does reverse this and puts the little a over sine A, little b over sine B, and little c over sine C. That's fine. It's the same thing. This is known as law of sines. And that's it. You're just going to use that to figure out side lengths, to figure out angles. And we're going to go slow. What's up, miss?
You just start with that formula?
I just started with the area formula, yep. And all three of those area formulas give me the same area for that one triangle. So, and then I just cancel stuff out, you know what I mean? Okay. All right, guys, so here we go. I have a triangle. I'm going to put not to scale. And I'm going to draw, let's see, I'm just going to draw a random triangle, A, B, C. And it says angle B is 64 degrees, so I come over here, 64 degrees. Angle C is 38 degrees, so come here, 38 degrees. And little b is 9 feet. So here's little b, this is 9 feet. This is little a, I don't know what that is. This is little c, I don't know what that is. Find length side A and side C. Okay, you guys ready? I'm gonna use my law of sines, and it doesn't matter. Well, before I do anything, I gotta find this third angle here. So how many degrees, the interior angles of a triangle sum up to how many degrees? 180. So go 64 plus 38. Let's see, 8, 9, 10, 11, 12. So 2, 1, 6, 7, 8, 9, 10. That's 102 degrees. And then go 180 minus 102. So what's that? 180 minus 100 is 80 minus 2, 78 degrees. I make mistakes all the time, guys, so make sure. Okay, are we still okay? All right, here we go. I'm just using my law of sines. I would use the sine 64 over 9 because that's perfect. So I'm going to go sine 64 degrees over 9. So the sine of angle B over little b equals, and then I want to find angle A first because A comes before in the alphabet. So I'm going to write sine 78 degrees over little a. And that's it. You're just doing cross multiply divide, guys. So cross multiply. Child, what do you mean by cross multiply? Just cross multiply. Set them equal to each other. So A sine 64 degrees equals 9 sine 78 degrees. Are we still okay? How do I get A by itself? Yeah, divide by what? Sine of 64. So there it is. Whatever you do to one side, you do to the other. So little a is equal to 9 sine 78 degrees divided by sine 64 degrees. There it is. That's my little a. Well, I guess let's see what that is. I take my calculator. You guys have your calculator. Make sure your mode is in what? Degrees. Let me higher my brightness here. Clear that. Alpha y equals, and I already forgot, short-term memory. 9 sine 78. 9 sine 78 divided by what? Sine 64. Did you guys get 9.7946? Okay. 9.7946. I need units. Feet. All right, here we go. I'm doing the other one. I'm changing my color. So I found this one. Oh, I guess let me continue that with red. 9.7946. Yeah, if you're in radians, you're going to get a different answer, guys. Make sure your mode's in degrees. All right, I'm going to start with the same one. Sine 64 over 9. Chop, why are you starting with that? Well, I could use sine 78 over 9.7946, but that's rounded. See, that keeps going. So I want to use something that's perfect. So sine 64 over 9 equals, and I want to figure out the C1, so I need sine 38 degrees over little c. Do you see what I just did, guys?
Wait,
What's up?
what is sine 64 was it A, right?
Sine 64 was, that's the b, sine of b over little b. See, that's this. Doing that part. All right, here we go. Cross multiply. So 9 sine 38 degrees equals c sine 64 degrees. And then to get c by itself, I got to divide. So 9 sine 38 degrees divided by sine 64 degrees equals little c. Let's see what that is. 9 sine 38 over sine 64. Alpha y equals, enter, 9 sine 38 divided by sine 64. 6.164875. 6.16, I already forgot. 4875. 4875. And I need units. There it is, guys. How do we feel? Okay. Perfect. I accidentally made the same angles here. It's the same process. Do you guys want me to do this one just to get more practice, or no? So you guys are okay? Are you sure? All right, let's keep going. This is from UH. It says, draw a triangle ABC with side BC as a base. The measure of angle A is 60 degrees. If a perpendicular is drawn from B to side AC, the height is 8 centimeters. What is the length of side AB? Okay, so let me draw my triangle. BC is the base, so you want that to be horizontal. So let's see, BC. So that has to be A. The measure of angle A is 60 degrees, so 60 degrees. If a perpendicular is drawn from side B to side AC, or from B to side AC, so I'm vertice B. All right, so here's my perpendicular. That's supposed to be 90 degrees right there. What is the length of side AB? So they want this. I'm going to put X. And this is 8. So do you see this triangle right there? All right. Looking at that triangle right there, guys, here we go. I'm just using law of sines. Sine 60 degrees over 8 centimeters equals, and right here, this is a 90-degree angle, equals sine 90 degrees over x. Are we okay? Okay, all you're doing is solving for x, cross multiply. X sine 60 degrees equals 8 sine 90 degrees. Divide by sine 60, so x equals 8 sine 90 degrees over sine 60 degrees. This one has perfect angles, guys, so try not to use a calculator for this one. Try. 8 sine of 90 is 1. Do you remember what sine of 60 is? See, the unit circle doesn't go away. No, the other one. Square root of 3 over 2. Keep, change, flip. Some people don't like that, the keep, change, flip, which is fine. 8 times 2 divided by square root of 3. So this is There is another way. Do you guys want to see the other way? If you were to recognize this, the one that's highlighted, if you were to recognize, Chop, that's a 30, 60, 90 triangle. And in a 30, 60, 90 triangle, the formula is n square root of 3, 2n. This is the hypotenuse, so technically this is x, so 2n is x, technically. What I have is a long leg, which is 8, so I would write an 8 here. So to get the hypotenuse, you need to first get n. So n square root of 3 equals 8. Then I would have divided by square root of 3 to get n by itself. Divide, divide. So n equals 8 over the square root of 3. And then look, to get x is 2n. To get x, all you got to do is double it. So 2n, which equals x, is double of 8. So 8 square root of 3, 8 over square root of 3 times 2. So x equals 16 over square root of 3. See, you would have gotten the same answer either way, guys. Hopefully you're getting stronger. Come on, parent. Hopefully you're getting stronger and you feel like, look, these are typical, this would be like a typical SAT question, ACT question that you would get. You can do it really fast, see? Cool or not cool? All right. This one's coming from UH. I wouldn't be surprised if you find this question in like an entrance exam. Find the area of a regular hexagon inscribed in a circle, radius 4. Guys, you don't have to know the area of a polygon for a regular polygon. I think it's like 1/2 apothem times perimeter or something like that. I don't know. See, I don't even know if that's the exact answer or not. Guys, draw a hexagon. Do you know how a hexagon looks? How many sides?
6.
6 sides. Well, for a regular hexagon. And then look, you have draw a triangle from your, or I guess connect every vertex like that. See? Chav, I don't know how to calculate. Guys, we just figured out how to find area of a triangle. 1/2 AB sine C. We already know that the radius is 4 centimeters, so that means, look, you have a circle right here. It's inscribed. So that means this is 4, and this is 4. So all I need is this angle right here. Chav, I don't know how to get that angle. Guys, use your logic. You guys are smart. You can do this. Look, one revolution like that. Isn't one revolution 360 degrees? How many triangles do you have there? So go 360 divided by 6. 6 goes into 36 6 times, so this must be 60. So that means theta 1 right here is 60 degrees. See, you don't need no formulas. You can do that. You're smart. So I'm going to figure out the area of that one triangle. And then once I figure out the area of that one triangle, I'm going to multiply it by how many? How many triangles do you have here? 6. Once I figure out the area of that one triangle, multiply it by 6. So area of that one triangle is 1/2 times 4 times 4 sine of 60 degrees. Let's see, half of 4 is 2, so 2 times 4. And then sine of 60, we just did that. That's square root of 3 over 2. That 2 cancels out with the 2 in the bottom. Because the area of a triangle, when we did it last time, was with sine. And I have 4 square root of 3. Are we still okay? That's the area for one triangle. How many triangles do we have? Multiply this by 6. Multiply by 6, since hexagon has 6 triangles. I'm trying to write good notes for you guys. I hear you guys. You guys told me you guys want more detailed notes. Here I am, more detailed notes. I listen to y'all critics. I listen to your feedback. What's 6 times 4? 24, right? 6 times 4, 6, 12, 24. 24, square root of 3. And since they put units, square centimeters. Don't call that centimeters squared, that's square centimeters. Did all that make sense?
Wait, why is it square centimeters?
You can say centimeters squared, but it's preferred square centimeters. If you look at the floor in Kathy's tile, Do you say, are those 4 square tiles, or do you say 4 tile square? Oh, you say 4 tile square? Okay, that's fine. Most people, when you go to Home Depot, you say, I need 20 square tiles, because tiles are square. All right, here we go. I think this is the last two. We've got 2 left. That's it, guys. Just 2 left, and then we'll set you guys loose. In acute triangle ABC, the measure of angle A is 2x. Okay, so let me draw a triangle. Not to scale. Not to scale. A, B, C. Measure angle A is 2x. The length of AB is 4. They don't give me units, so I'm just going to put 4. And the length of AC is square root of 3. If sine x equals 1/5, what is the area of the triangle? You will need to use the double angle formula for sine. Okay. I have everything I need. Bless you. Guys, I have everything I need to figure out the area of this triangle. Area of this triangle is 1/2 4 times square root of 3 sine of 2x. That's what we figured out last time, that the area of a triangle is. But here's the issue. I need to expand sine of 2x. Do you remember what sine of 2x is? Side note. Sine of 2x equals, you don't remember? All right. Do you remember what sine of a plus b is? What's sine of a plus b? Sine a cosine b plus cosine a sine b. Look what happens if I replace that b with an a. Oh, look. Sine times cosine is the same thing as cosine times sine. I have the same argument. How many of them do you have? Not everyone at the same time. 2 of them. So sine 2x is just... Guys, you gotta know some of these. I know you'll have a formula chart, but come on, guys. What if you were taking an AP exam? There's no formula chart on that. Yeah, we've been doing this a long time. There's the danger of using ChatGPT and AI, guys, because you let the computer do all the work for you and you never memorize anything. You do by repetition. If you go through the sweat, after you do it 3 times, you'll know it. So try not to depend too much on AI. All right, here we go. I'm just gonna distribute. 1/2 times 4 is 2, so I'm gonna write 2 times square root of 3, and then that sine 2x I'm gonna replace with 2 sine x cosine x times 2 sine x cosine x. I know what sine x is because they give it to me right here. I'm gonna draw a triangle, a right triangle, and I'm gonna put x right here. I'm gonna put a 1 right here, and I'm going to put a 5 right here. All I'm doing is SOHCAHTOA. Sine of x is 1/5, so I need the adjacent. So to get the adjacent, what's 5 squared? 25. What's 1 squared? 25 minus 1? So this is the square root of 24. And remember, 24 breaks up 6 times 4. And what's the square root of 4? 2, and I have the 6 still under the radical. So I got everything I need. I'm going to bring this down here, guys. So let's see. 2 times, I guess I'll write it like this. 2 square root of 3. And then times 2 times 1/5 times, and then I need cosine x. Well, cosine is 2 square root of 6 over 5. Yeah, adjacent over hypotenuse. All right, here we go, guys. This is like over 1, and this is like over 1. Don't worry, we're almost done. We just got one more after this. 2 square root of 3 times 2. That's 4. And then 4 times 2? 8. And I still have that radical. 8 square root of 6. Did I do everything correct? 1 times 1 is 1. 5 times 5 is... I see an arrow already. How come you guys didn't tell me? Yeah, what's square root of 3 times square root of 6? 6 square root of 18. And then 18 breaks down. Relax, we're fine. 9 and 2. What's the square root of 9? 3. What's 8 times 3? 24 root 2 over 25. Yay, we did it, guys. We did it. I'll move it up. Ask me questions. Did everything make sense? Rendon, did everything make sense? Or are you just telling me that just so we can move on? Last one. Don't worry, we'll be done real quick. If the area of triangle ABC is 14 square meters, so let me just draw some random triangle. So this is 14 square meters. Let's draw A, B, C. Little a is 15, so little a is 15 meters here. Little b is 8, so this is little b, which is 8 meters. Find all possible measures for angle C. Okay, here's angle C. I'm going to call it theta. Or theta. I got everything I need, guys. Look, I got these two segments that connect at C, and I'm looking for theta. I'm just using my area formula, guys. I'm just using my area formula. 14 equals 1/2 times 8 times 15 sine theta. All you're going to do is solve for theta. That's all you're doing. So 14 equals half of 8 is 4. 4 times 15, let's see, 15, 30, 60. 60 sine theta. Are we still okay? How do I get rid of that 60? Divide. So divide by 60. So 14 over 60 equals sine theta. And I'll slow down. I can see you guys writing super fast. Almost. How do I get rid of that sine? No, you're so close. Inverse. I'm going to write inverse sine of 14 over 60, which that does reduce, but you can leave it like that. Yeah, type that in the calculator. Oh, it has to be inverse because that's how you get theta by itself. This is sine of theta, so in order to get rid of the sine, you got to do inverse sine, and that's what cancels out the sine. All right, calculator, arc sine. Make sure you're in what mode? Degree. Arc sine, and you could, if you wanted to, reduce that to 7 over 30, but you can leave it as 14 over 60. It's not a big deal. 14 over 60. And there it is. I'm going to save that to C. You'll see why. 13.4933. So I'm going to write theta 1 equals 14.4933. That's truncated, right? 4933. Okay. Chop, why did you write theta 1? Is there another one? Oh, I wrote 14 and it was 13. Dang, man. Thank you. All right. That is one answer. Did they give you angle A and angle B? No, they did not. So you have another answer. Chop, what do you mean? Okay, think about it, guys. This is just from unit circle talk. If I don't write this down, just listen. If I told you, this is a side note. If I told you, give me all angles between 0 and 360, where sine of that angle equals 1/2. This is just a side note. You would tell me in quadrant 1, one answer is 30 degrees, and the other answer in quadrant 2 is, do you guys remember? There's one of them, and then this one. What angle is this? That's not 120.
Oh, that's 4 over 6.
You guys don't remember? Really? 150. Sine of 150 will give you that half. But guys, no matter how many times you tell the calculator to give you this one, it will never. They'll never give it to you. So how do I get 150 from my calculator? You just tell the calculator 180 minus 30, and it'll give you 150. See? Because the reference angle here is 30. It's the same with this. So if you want the second angle, just go. I stored it at C, so I'm going to put C. And I subtract that from 180. So 180 minus C. So here's my other answer, guys. So 166.5066. 166.5066. I'm going to store that to D in this one. Guys, it still gives you that same store alpha D. Check it out. Both answers work. Chav, are you sure both answers work? I'm going to type it into my formula, and I better get 14. So 1/2, so look, 0.5 times 8, with it times 15, sine of C. Obviously, this one's going to work. Oh, what happened? Oh, delete. Okay, now it should work. All right, look at that. Let me scroll up, and let's put the new angle that I got. I've stored that in D, alpha D. Let's see if I still get 14. See, I still get it. Cool or not cool? So this one has two possible angles. If they don't give you, and I know what you're saying, Chop, if theta 2, if that angle at C is 166, that means A and B are really, really small angles. Yeah, you're right. They're really small angles. They don't tell us what it is, but they're really small angles, and all three of them added together is 180. Are we okay, guys? All right, that was it. Let's start. We got some deltas, and that's all. Prepare. Oh, okay. I guess real quick. Hold on before you take everything out. We have, write this down somewhere. You're going to have a test. Well, actually, don't call it a test. It's more like a quiz. A quiz next Tuesday, so next week, over law of sines, law of cosines, and triangles, area of triangles. I will give you more work. We'll do review next week. Are you guys going to be here Thursday? Not everyone will be, but some will. I'll record it, and we'll have a review, and then we'll be ready for Tuesday. Cool, guys? There is a UH quiz. UH quiz. It's called Law of Sines and Cosines. Attempt by tomorrow, 0325, and due next week, before the day of the test. So 0331. Due 0331. I recommend you do them and get it finalized before we test. And then that's it. Just that and Delta Math. Cool or not cool, guys? All right, we're done, guys. You guys be good.